standalone solar PV system. Already two classifications is already completed. Coming to the third classification, the name of this classification is nothing but they come under standalone. So already I told what is the meaning of an standalone. If any system is self-sufficient of its own, then it is called as an standalone system. So for this load, this is completely defined with a solar panel, and for a backup it is designed with battery. So 100% the load can run. If the system is designed to run for 24 hours, then those sort of systems are called as a standalone system. So they are not dependent on any other battery, they are not dependent upon any other source of energy, they are self-sufficient with what they have. Therefore those sort of systems are called as a standalone solar PV system. Under this classification we are going to discuss today about the next classification is nothing but a solar PV system. So this is nothing but solar PV panel, group of solar panel which is called array with DC load. What kind of load you are going to have? DC load. This DC load may be a DC fan or like what is called irrigation pump. So irrigation solar pump, or this DC load may be an what you can say an flood lamp or street lamps. So a solar PV system with which type of load? DC load. So they will operate with DC voltage. So this DC voltage means what you can see this flood lamps or street lamps which operate with the DC supply, especially for this sort of application, solar street lamps. Or sometimes you can have in agriculture agricultural solar pumps. So those also run with the DC supply. Okay. And next with electronic control circuit or electronic control unit. So what is this electronic control unit? Okay, so this part is called as a electronic control unit. This take care about all the variations which are occurring in solar PV system. So in the solar PV system, this is what? Solar PV array. So this is nothing but group of solar panels which are connected in series connection or in parallel connection. So here what is going to happen is your power density is going to vary. So the power density units is watt per meter square, 1000 watt per meter square. The power density is varying, but load should not have that variations. Load should happily run with the required speed. If you want to have like this, then you require an electronic control circuit which take care about. So here indirectly you are going to have two internal parts in it, where the first one is called as a charge controller and next one is called as maximum power point tracking. So what is this charge controller? I already told the charge controller is like an electronic circuit or like an voltage regulator. So here what is its purpose is this take care about overcharging. It protects the battery from overcharging and protects the battery from over discharge. So we are protecting the battery from what? Overcharging. For example, solar is available, the battery is full, but still if there is no charge controller, the voltage will be pumped into the battery. So where the life of the battery or life cycle of battery is going to vanish. So by using this charge controller, we are going to protect the battery from overcharging. For example, so battery is 100% state of charge is there. Okay, so you start discharging the battery and it has reached 10%. If you discharge the battery more than 10%, like 10% state of charge, the battery life is going to decrease. So now automatically I have to turn off the load. That's why we are going to enable the concept which is called as over discharge. So this charge controller will protect the battery when it is going less than 5% of discharge, and it is going to isolate the load or turn off the load and protect the battery from over discharge. That's how the concept of charge control is. It protects the battery from overcharging and it protects the battery from over discharge, and indirectly it will act like an voltage regulator. So we convert this variable voltage into a constant voltage with the help of a battery. So battery is like a bridge network. It's not like a bridge. It's a bridge which take care about the solar panel and which take care about load. It's like an intermediate component which governs both. Okay. So now here what is the main importance of this? Here load can be operated for how many hours? 24 hours, because at the morning time solar array will be there, voltage will be there, and this voltage will be used to charge the battery, and when you turn on the load, the battery starts discharging and the voltage is available. You can turn on your solar pump and you cannot, if you want to turn on the fan, lights, loads, you can turn on. So for example, there is no after 6 o'clock there is no solar radiation or there is no availability of solar power. Already in the morning the battery has been charged from 10% to 100% state of charge. Now at evening the battery starts discharging and it supplies the required amount of power to the DC load. Therefore DC load will operate for how many hours? 24 hours. Okay. So like this, this is important classification in. So all these comes as examples of off-grid. All this comes as an example of off-grid. Here there is no grid. So these sort of configurations are generally used in hill areas where you don't have the availability of electrification. Okay, so some hilly areas or isolated areas. So where we don't have the transmission line and the transmission department has not connected the transmission. Therefore, at those sort of locations, solar PV system with type of load, DC load and electronic charge controller and a battery will make the customer to run the load for 24 hours. The problem here is we have to operate only this type of load, DC load. Now we are going to change that modification and we are going to add an AC load. Same configuration. So this is also which this comes under on grid or off grid. Off grid means generally to that village there is no grid, there is no power supply, there is no service grid. So with the electrification is not there in that village, then you can use this configuration and you can supply the power to the village. So here what is the next off grid classification is solar PV system with system load. DC load is there and AC load. And that also you can operate it with help of electronic control. For backup, what are you going to have? The battery. Same configuration we are going to redraw. So you are going to have a solar array which we are going to call as a solar PV system, and the input given the what is the name of this part? Electronic control unit, which consists of charge control and MPPT. Already we know about very clearly about MPPT. So MPPT is nothing but when you draw the current versus voltage, at one point it can catch a maximum current, at one point it can catch a maximum voltage. Where this point is called maximum power. Already we discussed. So this is electronic circuit which captures the maximum voltage and maximum current from the solar panel, and will try to give you the amount of power, maximum power that is taken care by MPPT. So now this electronic control unit also consists of what? Charge controller as well as it consists of maximum power point tracking. So what is the purpose of charge controller? It protects the battery from overcharging, it protects the battery from overcharge. Due to this charge controller, the life of battery or life cycle of the battery is going to increase. The life or the life cycle of battery is going to improve. So that's why electronic control unit consists of an charge controller and consists of an MPPT. Sir, what is the main purpose of MPPT? The main purpose of MPPT is to extract the maximum power from the solar. So we are not rotating the panel, we are facing south direction, facing Chennai, and we are trying to extract the maximum voltage and current. Therefore, the maximum power can be extracted from the solar system by using electronic circuit called as MPPT. There are some number of algorithms in it, so we can observe the maximum voltage and current. So now, after the electronic control unit, if you have DC load, directly positive terminal and negative terminal is connected. So here this DC load, you can operate an solar pump or you can operate a solar lamp. So some may not have, because DC loads are very costly. We need to have which type of load? AC load, normal fan and normal tube light. So therefore, I am going to take tapping at positive terminal and I am going to take the tapping at negative terminal, and I am going to use a small micro inverter or small inverter around 1000 VA. A small 1 kilowatt inverter, and I am going to convert the DC supply to AC supply, and I am going to connect to load. So that load may be an AC tube light, AC charger or AC. So here in the DC load also you can connect your mobile phone. Why? Because the USB is there, no? So you can have Type C, and on the other side you can have USB. So USB directly can connect to the charge controller. I'll show you this answer. Okay, so here we are going to have this solar PV system with AC load as well as with DC load. So in this AC you can connect the DC load as well as you can connect your AC load. So this is called as electronic control unit. This is not a system. So the system, you can see here, you can connect the positive terminal of the solar panel and you can connect the negative terminal of the solar panel. And here you can connect the battery. So here you can connect the battery positive terminal, and here you can connect the battery negative terminal. And here you have loads. All these three are loads. You can connect the bulb load, fan load and bulb. All are loads. Okay. So when you open this, you can see this circuit. Okay, how it resembles. So this is nothing but IGBTs. 1, 2, 3, nothing but the full bridge IGBT, which will convert. So this way is inverter or rectifier. It's only like an which converts DC to DC converter. Okay, so this is nothing but we are going to have the DC to DC converter, and this is nothing but the heat sink. So these are nothing but the IGBTs and all the program MPPT program. So the MPPT program and the purpose of the charge controller, everything is written the code in this Okay, through this microcontroller, everything is given, and you can see all inputs. So here you are going to give the DC input, and here you are going to connect the battery. The battery will act like a governor between I and this and the on the inputs. Okay, so this is like the design. Here you can see okay. So through this USB, what you can connect your mobile phone charger and start charging your mobile phone. There's no need of an extra charger. Okay, so by using this battery, we can charge. You can charge your mobile phone anytime with the power. Okay, so this called as generally there. When put in circuit, you can run the circuit. It's like we have this. I told we are going to extract the maximum voltage and current. So we are going to extract the maximum voltage and current. We have a number of algorithms. All those algorithms implemented is Microsoft through a computer, and the problem about the solar power is given. Automatically try to capture that maximum voltage and current, and it will try to maximum power in battery. If the battery is full, automatically it will try to discharge. We have an experimentation part. On this, we try to do that experimentation. This like what actually what is the name of this board? Electronic control units. It will perform two actions. So this board, so when you connect the load here, so this board will protect the battery from. Here also you have a protective circuit. So this will take care about the battery overcharging and over discharge. So this is how electron charge roll is designed and how it operates. Okay. So it's like when you go in detail, then you can understand. It will give some indication also. Whether if any problem is there, any fault is there. All the things is embedded in this microprocessor. Okay, so this is about the four configurations. All these are grid connected or without grid. Without grid is technically as off-grid solar PV system. So first one is off-grid solar PV system with only DC load. Next one, second classification is off-grid solar PV system with DC load and DC load and electronic control circuit. So which will have regulated voltage. Next one, we are going to have an DC load, electronic control unit and battery. Therefore, you can run it for how many hours? 24 hours. Fourth classification is you have an solar panel, electronic control unit and battery. The problem is only with DC load. So I am going to have an AC load with the help of a small inverter which is called micro inverter. So by using this micro inverter, the output may be an phasor neutral. We can connect an AC fan, AC tubelight or AC water appliances you have, water purifier, everything. Okay. So these sort of systems are which type of systems? Solar PV systems which are called off-grid types. Off-grid means there is no grid in that location. There is no availability of electrification in that location. Then you can use this configuration and you can supply power to those people. So now this is about off-grid system. Now we will discuss about on-grid system. How many on-grid classifications are there? And we will try to perform an experiment on off-grid system and on-grid system.